All right, we're in section 5.2 today, solving systems of linear equations by substitution. So really the only difference between 5.1 and 5.2, we're still solving linear systems. And that's what we're doing all of chapter 5, solving linear systems. And our solutions are ordered pairs, whether it's a graph, elimination, substitution. I'm looking for an ordered pair that can be a solution to the system. All right, so with substitution, this first one, we've actually already solved this problem, so I just wanted to kind of review over it with you guys, and then we'll get into some other ways that we need to look at these problems. All right, so in your notes from Friday, do you see this system? Y equals 2x minus 4, 7x minus 2y equals 5. Do you guys see that? Everybody kind of pinpoint in your notes where that is? And we're looking for the simpler of the two equations, and what I mean by simple, one of the equations should be solved for x or y already, where it's by itself. So which equation would that be, Sarah? The one on the left. Y equals 2x minus 4. And we're going to view this as an expression that y equals 2x minus 4. So we can take that whole expression, and where would we plug it in on the second equation? Where would that fit into the second equation? Does anybody know besides Sarah, maybe? Mason? I would plug it in for y. How do I know that? Because it says y equals. So I plug this whole expression in for y on the other equation. All right, so we plug it in. And now 7x minus 2, and now I plug in this whole expression, 2x minus 4 here, where y originally went in the equation. 2x minus 4 equals 5. Now my goal here is to solve for x. I can solve for x, but I need to use some of the practices that I've already learned in chapter 1, like distribute a property. Okay? And guys, I need to add a little side note here. You're becoming too dependent on your calculators. We can do 2 times 2, okay? I think we're just becoming a little too dependent on our calculators, where I see you guys using your calculators for calculations that are very, very simple. So what we're going to start doing is kind of like you could call them pop quizzes, where we're sharpening those mental math skills and not using our calculator. It doesn't necessarily connect straight into our lesson, but what's happening is you're moving on through high school, and you can solve these really extremely difficult algebraic problems, but you've forgotten how to add fractions or subtract fractions or convert fractions and decimals. And your college entrance test to get into dual enrollment, you're not allowed to use a calculator, okay? So, all that being said, let's try not to use our calculators whenever possible, so we keep those mental math skills sharp. What's negative 2 times 2? Negative 4. All right, that's very simple for us to do in our head. What's negative 2 times negative 4? Not negative 8, positive 8. Negative, yes, negative times a negative. Yeah, but that's good because we're sharpening those skills, so we might have forgotten that when we multiply 2 negatives together, that actually equals a positive. Okay, equals 5. Now, we're not ready to start moving yet, because is there a like term that I can combine over here? Yes. Which is what?
7x minus 4x.
Very good. And now I have a 2-step equation, subtract 8. I get negative 3, and then I get negative 1 for x. So this is part of my solution. Negative 1 is my x value. How can I use that information now to solve for y?
Plug it in for x on the other side.
Very good. Now, technically, I can choose either equation. I can choose this one, or I can choose the second one. The reason I want to choose the first one is because y is already isolated. So what's 2 times negative 1 if I plug that in? Negative 2 minus 4 is negative 6. Okay? And that's my solution. And remember, guys, this is saying if I plug it back into the original and I say negative 6 equals 2 times negative 1 minus 4, that's true. So it's one thing for an ordered pair to be a solution to one equation. There's a lot of ordered pairs that could be a solution to one, but it's really this one too. The fact that the same ordered pair can be a solution to a totally different equation. Let's try it. I want you to plug this in to your calculator. 7 times -1 minus 2 times -6. Just punch it in real quick because we're checking. What is that going to be? It's 5. Okay, so when I multiply those and subtract them, it's also a solution because that equals 5. 5 equals 5. So there's only one potential solution to a linear system. There's only one ordered pair that could be a solution to both. Do you see what I'm saying here, guys? The ordered pair I can plug back in and it makes both sides equal. All right? That's what I'm looking for. All right, so that's the one that we've already done. Now let's look at a couple others. All right, we have x equals 4y, and then x plus 4y equals -8. Okay, so again, we need to solve the system by substitution, basically meaning that one equation is going to have x or y solved for, and then I can substitute that expression in for the other one. All right, so let's go ahead and do that. X equals 4y gives me a value for x. What can I do with 4y now in the other equation? Plug it in for x. That's exactly what I'm going to do. Plug in 4y for x, and now I can solve for y on the other equation. Go ahead and solve for y on the other equation. All right, so we're going to plug it in. Okay, once you have y, now go back and solve for x. Okay, so we plug in 4y. Do you need a calculator to do 4 plus 4? No. So, guys, you're going to find that once you really ask yourself, do I actually need a calculator for this? Once you actually ask yourself that question, your answer is going to be no a lot of the time, that you don't need a calculator. 4 plus 4 is 8, right? 8y. What are you going to do to both sides now? Divide by 8. Y equals what? Trey, what are you going to do from there? Okay, so very good. So you know that y equals -1. So now you can take that and you can plug it back in here. He did, but I think he meant to solve for x. So what's 4 times -1? Shantanique, what'd you get? What's 4 times -1 up here when I plug the y back in? Anthony, what'd you get? Are you working the problem back there? Okay, what'd you get when you plugged in -1 back into the equation? What did you get for x? -4. Very good, -4. Okay, so -4, -1. What does that mean? That means if I plug them in for x and y into both equations, it makes it true. And for it to happen twice like that is actually pretty unusual. All right, we really only have one solution. Okay, next one. Y equals x minus 8, and y equals 2x minus 14. Go ahead and write down that system. All right, got it written down? So which one of these has the variable by itself on one side? Wait a second. Okay, so this one, the first one for sure. What about the second one? Oh, wait a second. The second one also has y solved for. So anytime you see both equations with the same variable solved for, here's what that means. That actually means that the expressions are equal to each other. All right, and think about it in substitution terms. Well, y equals x minus 8, so if I plugged it in here for y, I'm basically making the expressions equal to each other. All right, so x minus 8 equals 2x minus 14. All right, and what value do we know is understood in front of the x? 1. Okay. Now we see something that we really haven't seen much of since chapter 1. We see a variable on the left side and we see a variable on the right side of the equation. We can't just add them together. That equal sign means that's going to involve opposite operations. All right, so here's your choice. You can subtract 1x and move the x's to the right side, or you can subtract 2x and move the x's to the left side of the equation. All right, there really is not a wrong choice, but here's my rule. I move the smaller of the two variables. Do you remember me telling you that in chapter 1? Do you remember me telling you that in chapter 1? So if I subtract 1x to the other side, okay, now I'm moving my x's to the right side of the equation, which means what has to happen to my numbers? They have to move to the left side of the equation. X has to be on one side, my numbers have to be on the other. How can I get negative 14 to move to the other side? I need to add 14. So it cancels it here, and I add 14 here, and my x's are canceled over here. All right? So negative 8 plus 14 is 6, and 2x minus 1x is just 1x. So x equals 6. Okay, see what I did there? So I moved my x's to the right side, which means I had to move my numbers to the left side. So now I have the first part of my solution. Does the 6 go on the left side of the ordered pair or the right side? Left. The left, because it's x. All right, I want you to go ahead and find y.
Negative 2.
Yay, negative 2, very good. Okay, so y is going to be negative 2. Okay, so very good. Now, here's my last one. Okay, well, I say my last one before we have our modeling real life problem. Okay, so go ahead and write down this system. All right, what do you notice about this system compared to the other ones we've solved? Mason? Yeah, they don't have a variable solved for. So in the initial system, I don't see x equals or y equals. Okay, but I do see an equation that would be, I'd say, fairly simple to get x by itself or to get y by itself. Okay, do you kind of see one of them that might favor over the other one that would be easier? Very good. X plus 4y equals 14. And I would say that x is the easier variable to solve for because it's by itself, meaning no number attached to it. Okay, so if I wanted to solve for x, what can I do to both sides to solve for x here? I need a minus 4y from both sides. Okay, and now I have x equals negative 4y plus 14. Okay, and now I have my expression that I can substitute. All right, so you might face one of these where you don't have one of the variables solved for, but it could be an easy step to get there, and now you can make your substitution. So I want to kind of let you loose on this one. You make the substitution, solve, and then go back and plug it in and solve for the other variable. It is negative 8y. Okay, here we go. So we plug it in. We plug it in for x. Okay, we plug it in for x. 3 times negative 4y is what? What's 3 times negative 4? Just pay attention up here and I'll walk you through it. What's 3 times negative 4y?
Negative 12y.
Negative 12y. Okay, so here I am over on the right side. Okay, so I get negative 12y. What's 3 times 14? 42. Okay, don't add it. It's 42. Okay, plus 4y equals 22. Don't forget that you have like terms over here that you need to combine first. What's negative 12 plus 4?
Negative 8.
Negative 8y plus 42 equals 22. Now, yes, you have to move what's not connected to the variable first. Subtract 42 from both sides. Negative 8y equals negative 20. This might be the part where you think, oh man, like I did something wrong because this isn't going to work out to be an even number. but that's okay. All right. You actually are just going to get negative or positive 2.5, and that's okay. Yep, it's positive. 2 negatives.
Oh, yeah.
All right, what do I do with that value to now find my x value? What can I do with it, Elizabeth? Plug it back in. Now, I would plug it back in up here, all right, where it's -4 times 2.5, which is -10, plus 14 is 4. All right? And again, here's what it's saying. This is a solution to this equation and to this equation. That's my system. All right, so how does this look in real life? Okay, how does this look in real life? All right, well, let's read this problem to yourself as I'm reading it. Okay, you're planning a birthday party. You buy a total of 50 turkey burgers and veggie burgers for $90. You pay $2 per turkey burger and $1.50 per veggie burger. How many of each burger do you buy? All right, so that's a lot. All right, so I need to show you now how this actually breaks down into 2 equations. Are you with me? All right, so, and it's going to be for every system that we solve this way, I'm going to set it up in generally the same way. So that's the good news to this, that there is actually something that you can look for these patterns. All right, so here we go. Please pay attention, okay? So you buy a total of 50 turkey burgers, but you don't know how many turkey and you don't know how many veggie. That's one of your equations where it's basically your categories. So it's not specifics. So I'm going to call this my categories equation. What do I mean by category? One of the variables stands for, in this case, turkey burger, and one is veggie burger, and it gives me a total number of burgers. Okay, so this is my category equation. Now I'm going to have another equation. How much were turkey burgers?
$2.
So 2 times x, because I still don't know how many turkey burgers, plus, what do you think I'm going to connect to y?
Plus
150 y. Equals how much money did I spend?
equals 90.
$90. Okay, so here's what I'm saying. $2 times not sure how many turkey burgers, $1.50 times not sure how many veggie burgers, but I spent $90 total. So now I have my system. All right, so you could say that this is your specifics or your costs. Okay, so you're going to have an equation that really kind of breaks it down. All right, but I'm not ready to substitute because neither of these have solved for x or y. But is one of them probably going to be easier?
X plus y.
Yes, very good. So this one, it's only one step to solve for one of the variables. Let's say I want to solve for x, and I'm just going to kind of push you to solve for x in any of these scenarios. Okay? How are you going to solve for x? Just minus y from both sides. And now you have something that you can substitute in for x. You have 50 minus y, and where are you going to plug that in on the other equation?
On x.
In for x. All right, go ahead and plug it in and solve for x. Solve for y. Solve for y. You got this. I know you can do it. Okay, so now I plug in 50 minus y, and I distribute. What's 2 times 50? We don't need a calculator. What's 2 times 50? 100. Very good. Minus 2y plus 1.5y. All right, guys. Negative 2.5 plus 1.5 is what?
90.
Negative 0.5y equals 90. Okay, and now I'm going to solve my two-step equation. How do I get 100 to cancel to the other side? Minus it. So I get negative 10 equals negative 0.5y, divide both sides, and y equals 20. So what does this mean in terms of burgers? Or what I'm trying to figure out, how many burgers? You have 20 of which kind?
Veggie.
Veggie burgers. If you have 20 veggie burgers, how many, plug it back in, how many turkey burgers does that mean you had? You bought 50. So yeah, you have 30. If you bought 50 and you know you bought 20 veggie burgers, then you had to have bought 30 of the other kind. All right, and that's your answer, and that's everything you need to know for section 5.2.